Alright, so now we're looking at number 22, and we got CaBr2 plus AgNO3, and again we figure out that the Ca will join with the NO3 and we'll get the Br joining with the Ag. So now what we'll do is we'll try and figure out how these are going to combine. So we'll take one calcium over here, we'll take the nitrate over here as well. Remember, there's just a one NO3 group here because that's a polyatomic ion. Now over here we've got actually two bromines. Now I can prove that by drawing out a picture. It's going to look like Ca and Br and Br, and this is going to look like Ag and NO3. So you see, there's my proof that this is just one calcium, that's one bromine, that's one silver, and that's one nitrate. And that's all we're taking over here. And since we've got two bromines here and we just want the one, what I'll do is I'll just bring over the Ag and then one of the Brs over here. The common mistake here is to bring over Br2, but that would just be because it wasn't realized that this was actually two separate Brs. Alright, so now we've got that under control, what we're going to do is figure out what the charges are on each of these. Now we know that in the case of CaBr2, I'll draw a picture out again, we've got Br and Br. We know that Br has a -1 charge, and if we've got two of those, so that's -2, that means that the calcium must be +2 to match, so I'll make that 2 plus. The NO3 is going to be 1 negative. We get that off the polyatomic ion sheet. We know that if NO3 is 1 negative, the silver must be 1 plus. We already know that the bromide is 1 negative. Alright, so the next thing we're going to do is put all this together and figure out what compounds we're actually getting out of this. So it'll be CaBr2 plus AgNO3. And then we've got Ca2 plus and NO3 minus. And what I have to do with this is ask myself the question, well, how many of these groups, of each of these groups, do I need to make this a neutral compound? And since I've got a 2 plus here and a 1 negative here, I'd want you to see that you would need two of these NO3 negatives to balance out the +2 charge on the calcium. Here we just need one of each of the silver and the bromine. Now if I go take a look at the solubility chart, I'm going to find that this is a solid, and I'm going to find that that's aqueous. So in the tradition of what I was saying earlier, anything that's aqueous I'm not going to put an AQ on, but anything that's solid I'll put an S on. Alright, so that's part A. Well, no, not quite. We still need to balance out the reaction. We've got one calcium here, one calcium here. We've got two Brs here, only one over here. So I'll put a 2 in front of there. Now I've got two silvers, so I'll put a 2 in front of here. And now I've got two NO3s, and that matches the two NO3s I've got over here. So that's all figured out. So that's part A. Part B. What we're going to do is split all this up into ions. And if I draw pictures of this, here's what it's going to look like. CaBr2 looks like Ca and two Brs. Two AgNO3s look like that. And we've got one Ca and two NO3s. It's going to look like this as a picture. And the silver bromides are not going to split up at all because they're a solid. So I'm just going to leave that the way it is. Now I would need to put these charges on. I can just use the same charges as I found up here. So we've got Ca2 plus, Br negative, Ag plus, Ag plus, NO3 negative, NO3 negative, Ca2 plus, NO3 negative, NO3 negative. Alright, so now what I can do is I can go ahead and figure out what ions I'm going to get when these two split up. So this will split up into Ca2 plus and then two Br negatives. See, 1, 2 Br negatives. We've got two Ag pluses here. We've got two NO3 minuses here. Notice I put a plus sign in between each because these are splitting up into these ions. We've got one Ca2 plus down here, and we've got two NO3 negatives over here. And then we've got the silver bromide, of course, which does not split into ions. Alright, so that's part B answered. Now we're going to look at part C. And for part C, what I'm going to do is I'm going to copy what we got for part B. And now what I'll do is draw the net ionic equation, and I'll do that by for anything that appears that's exactly the same on both sides. I'm going to get rid of that. So we've got Ca2 plus and Ca2 plus, that's the same. We've got two NO3 negatives and two NO3 negatives, those are the same. So what we're left with is 2Br minus plus 2Ag plus gives 2AgBr solid. That would be the net ionic equation. Notice that this could be 2Ag plus 2Br minus, or 2Br minus plus 2Ag plus. It really doesn't matter. So that's how we're going to end up getting the answer for number 22.